Welcome to CW 9.4. Today we'll be talking about the law of sines. So take a moment and just copy that down. That's a law of sines. Hopefully you remember this from your trigonometry class last year. And if not, that's okay. We'll spend some time talking about it today. So now that you've gotten the law written down, let's go through a couple of examples here. So first one says solving a triangle given these dimensions. So let's first just start by drawing it generically, meaning this is not to scale. A, B, C, 75 degrees here. A is 51, and then B is 71. So looking at what we know, what you always want to do is this. Identify the, quote, pair. Meaning you want to identify the leg and the angle that correspond that we know. So for example, these two would be our pair because we have a corresponding length and an angle. Notice how we don't know the rest of it. We don't know little c, we don't know capital C or B. But we can use law of sines here. I can say sine 75 over 51, that should equal sine of B over 71. Let's multiply both sides by 71. So sine of B is equal to 71 sine 75 degrees over 51, which means B should equal sine inverse of 71 sine 75 degrees all over 51. Now go to your calculator. Make sure you're in degrees. Sine inverse is arc sine, so let's type that in. And let's plop it in. 71 sine 75 over 51. We get error. So when this happens to you, we got to figure out what is causing that. You can't just write error. So what we want to do is actually evaluate this thing right here. Figure out what that is. 71 sine 75 over 51. So I'm going to type that in. (71 sine 75 over 51). That's 1.34. So on the side, I'm going to write sine of B is 1.34. And that's a problem because sine of B is greater than 1, and we know that can't ever happen. So our conclusion is there is no solution. So that's how you will formally answer a question like that has no solution. You need to establish those three things. 1, 2, and 3. Now let's go to a little harder one. So same thing, let's draw a generic triangle here. A, B, and C. This is 43. Little a is 81. Little b is 62. And then once again, notice that you got your pair right there. It does give you rounding rules, but these are kind of weird. It makes it inaccurate. So I'd rather you take a moment, write these down. For angles, we'll go the nearest tenth, or one place. For lengths, we'll go nearest hundredth, or two places. Let's start by doing the exact same thing. Sine of 43 over 81, that's sine of B over 62. I'm going to skip the last step. B should be sine inverse of 62 sine 43 degrees over 81. Okay, now you type this in your calculator. So let's try that. Sine inverse of 62 sine 43 over 81, 31.5 degrees. So B equals 31.5 degrees. However, it's not that simple because we're dealing with sine. Think about what we did in a couple chapters ago. Let's say we said sine of b is equal to 1/2. We can do that in our head. It's 30 or 150, but the calculator will only give you the acute angle. So that's your calc answer. So what you need to do is get the other answer by hand. And the way you do it is you do 180 minus the answer the calc would give you, which in this case would be 30 in our example. So what you gotta do every single time when you do sine inverse like this is find the other answer by hand. We're gonna write or, and let's just do 180 minus 31.5. There's your other answer, 148.5. So we have to understand that trigonometrically, both of these answers would work. Now geometrically, think about it. Can we take this 148 and put it right there? No. This plus the 43, that breaks a triangle that's over 180. So we simply cross that out, and 31.5 degrees is the only answer we can have. Now we keep going. Now I got to figure out angle C. So just do 180 minus these two. So let's do 180 minus 31.5 minus 43, 105.5. And now we can find the last piece. Same thing, using law of sines. So we're going to type in sine of 43. Actually, I'll make it a little bit easier for ourselves. Let's put the 81 on top, so that way letter C will be on top too. Sine of 105.5. So C should be 81 sine 105.5 over sine 43. Let's type that in. 81 sine 105.5, and that is divided by sine 43. 114.45. And there's our answer, right there. Let's circle that, good to go. Okay, next one. Once again, we draw it generically. And let's fill in what we know. A, B, C. This is 40. A is 54. B is 62. And now it says, yep, let's figure it out. So here's our pair. And we know sine of 40 over 54 should equal sine of B over 62. So B should be sine inverse of 62 sine 40 over 54. Plug that in your calculator and you're going to get 47.6 degrees. Don't forget to do the 180 minus your answer, and that will give you 132.4 degrees. So I'll highlight those. Now this one's a little bit tricky because notice how if I grab this 132.4, this one will work because 132.4 and 40 would keep it under 180, which means both of these answers will work. So at this point, there are actually going to be two triangles. That's why in the header you see two solutions. So for now, don't worry about that. Let's just continue on with the 47.6. So fill that in right there, and then we keep going. If that's 47.6, this one should be 92.4. And then let's figure it out. So C over sine of 92.4, that should equal 54 over sine 40. So C should be 54 sine 92.4 divided by sine 40. In your calculator, you get 83.94. So there's your first triangle, not too hard. Now the second triangle, what's happening is this leg right here is basically swinging in. So I'll try to actually draw it for you. The triangle is basically shortening to something like this, where this is A, B, and C. This is still 40. This is still 54. This is still 62. Except notice how that angle is now obtuse. This is your 132.4. And if that's 132.4, this thing in here is going to be 7.6. So if I were to draw it in for you, it'd basically be like right around here. This is where the second triangle is existing. This piece right here. And now it's basically the exact same thing. To find C, we're just going to do C over sine 7.6 degrees. That's equal to 54 over sine 40. Let's work it out, and you get 11.11. So let's move that down there. And there's our two triangles that are possible. Okay, last one. It says find the area of a triangle having two side lengths of 24 and 10 and an included angle of 62. So basically all we know is this is 24, this is 62, and this will be 10. Let's make that a little more to scale. Let's say something like that. That's all we know. And we don't know this leg, we just know it's something. We got to find the area. So the area formula is actually quite nice. The area formula of a SAS triangle is simply 1/2 AB sine C. And this can be manipulated, obviously. It could be AC sine B, or it could be BC sine A. Now, what most people study is this first one, because that's like the easiest to remember, because it goes ABC. The main thing to actually remember is SAS. As long as you have SAS, you just use the formula accordingly. So watch this. 1/2, the two legs, which is 24 and 10, and then sine of the included angle, which is 62. So you plug that in, and this one we will actually round. You'll get 106 in your calculator, and we'll make that meters squared since it's area. Now you might be wondering, like, where does that even come from? So I'll show you really quickly. It's actually quite simple. I'll make a generic triangle like this. This is A, B, and C. And let's say we know A, B, and then we know this angle C. What you do, drop down this height like that. We'll call that H. And then we're going to say sine of C is H over B, which means H is equal to B sine C. Now you're probably wondering, why does that matter? Well, think about the area formula of any triangle is 1/2 the base times the height. We actually know the base. The base is right here, so that's A, and we just found the height right here, and look at that. That's the proof for the formula. And that covers it. So good luck on the questions, and let me know if you have any questions for me.